Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals, and here we are going to solve this problem with the help of one important property of definite integrals. So we are given this problem where we have a function f of x which satisfies this equation, that is f of x plus f of pi by 2 minus x is equal to pi for all values of x belonging to the set of real numbers. And we have to find out the value of this integral, that is 0 to pi by 2 f of x and sine 2x raised to 4 dx. So to solve this problem, we'll make use of this property of definite integrals, where we have an integral, say 0 to a, and if we have a function say f of x dx, then the value of this integral can be written as 0 to a, and we have f of a minus x dx. So this property of definite integral is an important property, and it is used to solve a lot of definite integrals, right? So here let us first take this integral as I, and we'll take this equation as equation number 1, right? So if we compare this integral with this one, then here we have 0 to a and here we have 0 to pi by 2. So we can take a is equal to pi by 2, and our function f of x is given by f of x, and we have sine 2x raised to 4. So now using this property, we can now write this integral I as 0 to pi by 2, and we have f of here we can now replace this these x by a minus x, right? So here we have x and here we have a minus x, so we can replace x by pi by 2 minus x. So we have pi by 2 minus x, and then we have sine, here we have the exponent 4, and then we have 2 times pi by 2 minus x and dx. So now let us solve this integrand. So we have 0 to pi by 2, and we have f of pi by 2 minus x, and here we have sine 4, and this is 2 pi over 2, that is simply pi, and then we have 2x, and here we have dx. Now from trigonometry we know that sine pi minus theta is equal to sine theta, right? So sine pi minus 2x is simply equal to sine 2x, and here we have the power or the exponent 4, so sine 4, and here pi minus 2x is equal to sine 2x raised to here we have 4, right? So we have now I is equal to 0 to pi by 2 and f of pi by 2 minus x, and this expression is equal to sine 4, and here we have 2x and dx, and let us call this equation as equation number 2, right? So now let us add equation 1 and 2. So when we add equation 1 and 2, we have I plus I, and then in the left hand side we have I plus I, and in the right hand side we have 0 to pi by 2 f of x sine 4 2x dx, and here we have 0 to pi by 2 and f of pi by 2 minus x, and then we have sine 2x, and here we have the exponent 4, right? So I plus I is simply 2i, and since the limits of integration are same in the both the integrals, so we have 0 to pi by 2, and we can take sine 2x raised to 4 as common, and we have f of x plus f of pi by 2 minus x, and here we have dx, right? So 2I is equal to 0 to pi by 2, and here f of x plus f of pi by 2 minus x is equal to pi, right? So we have here pi, so we have pi sine 4 2x dx, and we can now write I is equal to pi over 2, taking pi outside the integral, and we have 0 to pi by 2 and sine 4 2x dx, right? So let us call this integral as integral number 3. So now to get the value of I, we have to solve this integral. So now let us make use of the method of substitution to solve this integral, and let us take 2x is equal to t, right? So we can now write x is equal to t over 2, and if we differentiate x with respect to t, we have dx over dt is equal to simply half, because the derivative of t with respect to t is 1. So now from here dx is equal to dt over 2, right? Okay, now the limits of integration vary from 0 to pi by 2. So when x is equal to 0, then the value of t can be obtained from this relation. So we have 2 times 0, that is 0. And when x is equal to pi by 2, then the value of t is given by 2 times pi over 2, and this is equal to pi. So now this integral I can be written as pi over 2, and we have 0 to pi, because when x varies from 0 to pi by 2, then t goes from 0 to pi, and we have here sine 4, and for 2x we can write t, and for dx we have dt over 2. So here we have dt over 2. So now I is pi over 4, 2 times 2 is 4, and we have 0 to pi, and sine t raised to 4, and here we have dt. So now let us make use of some important identities from trigonometry to simplify sine t raised to 4. So now let us write sine 4t as the square of sine square t, right? So we can write a raised to 4 as a square whole square. So let us write sine t raised to 4 as the square of sine square t, and let us make use of the double angle formula for cosine function, that is cos 2t is given by 1 minus 2 sine square t, and if we rearrange the terms, then we get 2 sine square t is equal to 1 minus cos 2t, and sine square t is equal to 1 minus cos 2t divided by 2. So let us substitute the value of sine square t as 1 minus cosine 2t over 2 in this equation. So we can now write here the square of this term, because sine square t is given by this term. So we have 1 minus cos 2t divided by 2, and here we have square. So let us write it as 1 over 4. The square of 2 is 4, and here we can now apply the identity for a minus b whole square. So we have 1, then we have plus cos square 2t minus 2 times cosine 2t, right? Okay, now let us again make use of the formula for cosine 4t, right? So here we have cos 2t is equal to 1 minus 2 sine square t. So the formula for cosine 4t is given by 2 times cos square 2t, and here we have minus 1, right? So here we can again rearrange the terms. So we have 1 plus cos 4t is equal to 2 cos square 2t, and cos square 2t can be written as 1 plus cos 4t over 2. So now let us substitute the value of cos square 2t in this expression. So now we have sine 4t, and this is equal to 1 over 4, 1 plus cos 4t over 2 minus 2 cos 2t. So let us take the LCM here. We have 1 over 4, and we can now write here 2, and here 2 times 1 is 2, and then we have 1 plus cos 4t, and then we have here 4 cos 2t. So let us simplify it. So we have 4 times 2 8, and this is 2 plus 1 3, and then we have cos 4t minus 4 cos 2t, right? So viewers, the value of sine t raised to 4 is given by this expression, right? And now let us substitute the value of sine t raised to 4 in this integral. So we can now write I is equal to pi by 4, and we have 0 to pi, and then we have 1 over 8, and 3 plus cos 4t minus 4 cos 2t, and here we have dt. So now we can easily integrate this expression, because we know the integral of 3 dt and then cos 4t and minus 4 cos 2t. So here we'll make use of this result, that is integral dt is t, and integral of cos mx dx is given by 1 over m, and here we have sine mx, right? So now we can write I is equal to here 4 and 8 can be multiplied. So we have pi over 32, and then the integral 3 dt is simply 3t. The integral cos 4t is sine 4t divided by 4 due to this result, and then we have minus 4 times 1 over 2 and sine 2t, and the limits of integration are from 0 to pi. So now let us substitute the limits, and we'll take the difference. So we have pi over 32, and first we'll take t is equal to pi in this expression. So we have 3 pi plus sine 4 pi over 4, and here we have 2 times 2 is 4, then 2 sine 2t, so this is 2 sine 2 pi, and then we'll take t is equal to 0 in this expression. 3 times 0 is 0, then we have sine 0 over 4, and here we have minus 2 sine 0, right? Because when we take t is equal to pi, we have this expression, then here we have negative sign, and then we'll take t is equal to 0. This term is 0, this is sine 4 times 0, sine 0 over 4, and here we have minus 2 sine 2 times 0 is sine 0, right? Now the value of sine 4 pi is 0, sine 2 pi is also 0, because we know that sine n pi is equal to 0 for all n belonging to the set of integers, right? So this term is 0, this term is also 0, this is 0, and this is 0 because sine 0 is 0, right? So we are left with pi over 32, and here we have simply 3 pi, this is 0, here we have also 0, and here this entire term is 0, right? Okay, so now we have pi over 32, and here we have simply 3 pi. So multiplying these two numbers, we have 3 pi square over 32. So viewers, when we have a function f of x which satisfies this equation, f of x plus f of pi by 2 minus x is equal to pi, for all values of x belonging to the set of real numbers, then the value of this integral I is given by 3 pi square over 32. So this is how, by making use of this property of definite integrals along with some trigonometric identities, we can easily solve these kind of problems. Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this session we are going to solve this problem in which we are given two functions f of x and g of x such that f of x plus 2 times g of x is equal to e raised to minus x, and the derivative of f of x, that is f prime of x, is equal to f of x with f of 0 is equal to 1, right? So here we are given these three conditions, and we have to find out the value of this integral, that is 0 to 1 square of f of x times g of x dx, right? So let us see how we can find out the value of this definite integral using these three conditions. So let us take this integral as I, right? And here we'll start with these two conditions. So here we are given f prime of x is equal to f of x, right? So we can now solve this equation. This is a differential equation of first degree and first order, right? So here we have a df over a dx is equal to f, right? So here we are writing f of x as f. So f prime of x is equal to f of x can also be written like this. So now separating the variables, here we can write df over f, and here we have dx. So let us integrate both sides. So we can now write integral df over f, and here we have integral dx, and c is the constant of integration. So here the integral 1 over f df is simply a log of f, and here we have x plus c, right? So let us again replace this f by f of x. So we have a natural log of f of x is equal to x plus c, right? So now let us use this condition to find out the value of this c, that is constant of integration. So we have f of 0 is equal to 1. So let us take x is equal to 0 in this condition, or in this equation. So we have a natural log of f of 0 is equal to 0 plus c, and f of 0 is 1. So we have log of 1 is equal to c, and log of 1 is 0. So the value of c is equal to 0. So let us substitute this value in this equation. So we have natural log of f of x is equal to x plus 0, that is simply x, right? So now we have natural log of f of x is equal to x. Now taking the exponential of both sides, we have e raised to natural log of f of x is equal to e raised to x, and e raised to natural log of f of x is simply f of x, that is equal to e raised to x. So the function f of x is an exponential function, so f of x is equal to e raised to x. So let us substitute f of x in this equation. So we have e raised to x plus 2 times g of x is equal to e raised to minus x, and 2 times g of x is equal to e raised to minus x minus e raised to x. So g of x is equal to e raised to minus x minus e raised to x over 2, right? So now we have obtained the values of f of x and g of x. So let us substitute these two functions in this integral. So now we can write I is equal to integral from 0 to 1 and square of f of x, that is e raised to x square, and for gx we have e raised to minus x minus e raised to x over 2, and here we have dx. So let us simplify it. We can take half outside the integral. We have 0 to 1 e raised to 2x, and here we have e raised to minus x minus e raised to x dx. So we can now write half 0 to 1, and multiplying these two quantities by e raised to 2x, we have e raised to 2x minus x, then we have e raised to 2x plus x, right? Okay, so now we can write this integral as half, and we have 0 to 1, and e raised to 2x minus x is simply e raised to x, and here we have minus e raised to 2x plus x is e raised to 3x, and here we have dx. So now let us simply find out the value of this integral. So we have I half the integral of e raised to x is simply e raised to x, and the integral of e raised to 3x is e raised to 3x over 3, and the limits of integration are from 0 to 1. So here we have used these two results. The integral of e raised to t dt is equal to e raised to t, and the integral e raised to say m times t dt is equal to e raised to m times t divided by m. So here the value of m is 3, right? Okay, so now we can substitute the limits and we'll take the difference. So first we'll take x is equal to 1. So we have e raised to 1 minus e raised to 3 over 3, and then we have here x is equal to 0. So we have e raised to 0 minus e raised to 0 over 3. So this is half, and we have here e minus e cube over 3 minus here we have e raised to 0 is 1. Here also e raised to 0 is 1. So we have 1 minus 1 over 3, that is 2 over 3. So here we have 2 over 3. So let us simplify this expression. So we have I, and we have half, and 3e minus e cube minus 2 over 3. So we can write I is equal to 3e minus e cube minus 2 divided by 2 times 3 is 6. So this is the required value of this integral I when we are given two functions f of x and g of x, such that f of x plus 2 times g of x is equal to e raised to minus x, and f prime of x is equal to f of x, and f of 0 is equal to 1. So this is how, by making use of these concepts, we can easily solve these kind of problems.